When we talk about soil health, and we're talking in urban landscapes, as we look at these two different PEDs here, this one you can see has a lot of roots in it. It also has some smaller BB-shaped sized particles, whereas this one, which came from a construction site that was compacted, it looks a lot like a block or a clod is what we call it. So we have an aggregate when it's from a biological system, and when man creates it, it's called a clod. So the goal is to see what happens when these come into contact with water. So this clod will be represented on our pan in the middle, and then this aggregate is representative of our native pan that's on the far left-hand side of your screen. So we'll place these in water, and immediately you can see within these canisters that there's bubbles happening. So what's happening is the water is rushing inside whatever pore space is there. And in this one you can see it's not doing a whole lot, but we're getting a little bit of movement on the one on your guys' right-hand side. And the goal is to have this biology in our soils that cement and glue these soil particles, these individual sand, silt, and clay particles together. And that gluing keeps this soil intact. So in this canister, we have a soil that has biology in it. So the bacteria has polysaccharides that are like sticky glues that cement and hold those individual sand, silt, and clay particles together. And when we're in a perennial system such as native sod, we always have arbuscular mycorrhizae. That arbuscular mycorrhizae coats the surfaces of those with a protein called glycoprotein. Okay, so in this basket you can see we have a PED that has a lot of biology. That biology, when it breaks down, those micro and meso aggregates fall down into that can. That is what we want to see happen, because we know at that point when rainfall would interact with the surface of this PED, it's not going to break down. This clod is completely gone at this point, and it's in suspension in this canister. So all those individual sand, silt, and clay particles have broken apart. There's no cement holding them together, so there's not a lot of biological glues, maybe a little bit of bacteria, but not a lot. And they've got to have quite a bit of it to do that. And as you can see, there's kind of a gradation in here. So we're starting to get some settling of these soil particles. So up here in the lighter area, we'll have our clays, our very fine clays. As we move down in this gradation, we get a little bit more silts. And then finally down here at the base of this PED or can, you can see some sediment that is starting to stack up. So those will be our sands. So we've completely broken everything down into individual particles when we don't have the soil biology versus when we do. So the rainfall simulator is developed to showcase the amount of rainfall that comes down on the surface of one of these pans of management. All of the pans have perforations in the bottom, so they're completely will allow, if water will to run through and then go through a flume into these jars that you see in the back. So these will collect all of the infiltration. When we have any surface breakdown of the aggregates, like we showed in our slake tubes, when it lost all of the biology, then it will run off. And so it'll run through this flume and down here in these runoff jars. So let's look at our different types of management. So this one is, the Public Works is really interested in trying to get a lot of native grasses established. So what we have here is a little blue stem, and we've got some buffalo grass in the front. So it's a shorter statured grass that comes in and fills in rather rapidly, and it protects the soil surface. We call it an early successional grass because it does come in and it fills in those voids when we have bare soil. Then we have this second stage successional grass, which is this little blue stem. A lot of times we'll also have side oats in there, which is a really neat grass. It has a little flag, and it has all these little flags on the side of it, which are the seed heads. These native grasses evolved and developed in this part of the world, which is in mostly all of Kansas. So we start over here on the east side of the state with tall grass prairie, and as we move to the central, we'll have mid-grass prairie, which is around this size. And then as we move further west, we'll get into the short grass, which is the buffalo grass and a lot of our grandmas. These native grasses have their own biome. So any biology that we have in our soils evolved from having these grasses here when we were, before we developed the western part of the United States. So when we put these grasses back, there's some what we call morphic resonance, meaning the soil remembers. And the biology that's in the soil stays there for many, many years and will come back when it senses these root exudates that these plants start leaking out. But when we're in a construction scenario, it's always good to put in something that is an annual that covers the soil really rapidly. So what we have here is a wheat that was seeded at a full rate. So we're looking at 1 million pounds to the acre, and that's a general standard wheat rate. In construction, sometimes they'll do 1.5 times that in order to get enough effective cover, because a lot of the times that soil is really damaged because it's gone through that compaction and a lot of movement, and this plant will grow essentially on anything. Wheat will. And so this cover, you can see, covers all of the pan. You don't see any bare soil at all. So then when we do get effective rainfall, or what we call effective rainfall, will run directly into the soil. This pan is considered a constructed pan. It's been compacted. I packed this in here pretty tight. There is some loose soil on the surface, but we're going to look and see what happens. And you'll see a lot of similarities to that slake demo that we did, showing that clod that when it sits in there, it breaks down. So we're going to see how much this breaks down. And you'll also see that when that does break down, these little particles will break up and they'll fall and fill in any voids and stack up. Once they stack up, then they'll seal over, and then we'll get that runoff. This is the exact same pan, highly compacted, but in this case we've gone and put some dead mulch on the soil surface. So the intent of this dead mulch is to break up that rainfall impact. So when a raindrop's coming down from the sky, it's coming at about 25 miles an hour. So if you imagine you're in traffic and you run into someone that's in a car at 25 miles an hour, you're going to feel it. It really bumps. So imagine just the bare naked earth and that rainfall, that raindrop hitting that soil surface at 25 miles an hour, and that causes that explosion essentially. And then here we've got some soil sealing, some cement. And so we're going to look at what happens when we have these non-porous surfaces, and why it's important in some of our urban landscapes where we don't have a lot of heavy traffic, where we have to have really heavy cement with rebar due to heavy trucks. But in some of our urban areas where we're just living and residing, we could get away with putting some porous or semi-permeable types of cover, so that we can get water to run in and instead of running off of our urban landscapes. So I'm going to go ahead and turn this on, and then we'll take a look and see what happens. So the rain that comes out of this comes down at about 6 inches an hour. And from an engineering standpoint, when we build terraces in the Natural Resources Conservation Service, that's what we build our terraces to, is that 6-inch or 10-year storm impact is what they call it. So we'll go ahead and turn it on. Okay, so we're going to put about 1 inch of water on. That's why I have those rain gauges on the table. But you can see right away when we look at that tillage pan or the construction pan with absolutely no cover, it's pretty similar to like what we have in those slake jars where we ran that slake, where that clod went in the water and then it dispersed. And so on the soil surface, you can see we're getting that dispersion. You could see those soil particles on that backdrop. That's something we don't want to see specifically in our landscapes, urban or even rural or otherwise, because what's attached to those soil colloids a lot of times in our farming landscapes are phosphates. So the phosphorus ties to any clay particles, and then when that hits that, raindrop hits that and it explodes and runs off, then we end up having phosphorus running through and into our streams, lakes, and reservoirs, and that ends up eventually down in the Gulf, and that's why we have that hypoxia area. So when we put on some cover, whether it be living or in the case of our native pan here on your guys' left, that is really a living pan. it is photosynthesizing. There's some small green pieces in the buffalo grass. If you come up close, you can see it. So it's always leaking root exudates all throughout the year, unless you're way up north in the northern tier states where it really becomes a dormant scenario. But you can see on our cover crop pan, we're starting to take some water in. So we're getting some infiltration, and that's what we want. When we cover up these soils that have been damaged severely from this construction impact, we've got to get a cover on it. We got to get it quick, and that ends up with that living root, helping that biology rehabilitate and creating some porosity back in that soil profile. You can see even on our pan that has the mulch cover on it, we are getting a little bit of runoff. Not near the amount of runoff that we're getting on our tillage pan, which I see, there we go. Our tillage pan, I think we lost probably a 1/4 inch or more. That's just hitting the outside of the jug. But the thing is, it'll be usually clearer runoff because that soil is not as impacted from that scenario. Now you can see on our, because of the preferential flow around the edge of this concrete pan, I could not get it totally to adhere to the side of the pan. So what water is hitting the edge there is coming to the edge of that concrete. So say in your sidewalks, when you put those seams in, this is where that water is running in, is in those seams. So this is the seam of the sidewalk on the front of that pan. That water is running down in through that soil profile. So we got to be really careful about what we have out on those sidewalks and on our road courses. A lot of times there'll be motor oil there from in your driveways, or even in car parks, or along the street parking. And people are always dripping off motor oil. There's also soil that adheres to their tires that's up in their wheel wells that falls off. That gets on that impervious layer and runs off. We also have fertilizers in urban areas that run off and will get into that concrete, runs down to our water courses. We also have a tendency to see microplastics is another big new contaminant that we didn't realize, but we've had since what, the 70s and the 60s, when we started bringing petroleum-based plastic into our systems. Those microplastics are getting into our water courses off the surface of these impervious concrete surfaces as well. So we got about 1 inch of water. I'm going to go ahead and stop it. We'll let it trickle down a little bit, and then we'll discuss what we're seeing in these jars from a runoff standpoint and an infiltration. So in our pan that we have, the native grass, we have a little bit of runoff, but the nice thing about this runoff is that it's clear. Doesn't have much in the way of any soil contaminants other than what happened when I put it into this pan. It's pretty aggressive when we cut these, so I get a little bit of soil, but this is what we're looking for, is water that runs through. And if I had cut this a couple of weeks ago, I usually water it for a couple of weeks, and what runs in is usually pretty clean. The tannish brownish color from a lot of these pans that we have the native in is indicative of a sugar that's being released from that plant. It's not completely clear water. This has a little bit of sediment in it, so it is a little bit browner, but otherwise fairly clean runoff. On our cover crop pan, you could see any runoff that we got is clean, which is good. From a groundwater or a stream recharge or a pond recharge, not a bad thing to have, and that's why we keep the soil covered. And like I said, when I cut these, they get really hammered and damaged, so usually I keep them a week, and I water them for a good week, and it makes them more like they're actually from nature in that regard. But from the amount that we got to take in, pretty similar, a little bit more on our tillage pan because it was wet when I cut it. This pan of native was pretty dry, so it has more pore space, and so a lot of the water that came down is inside those pores, and any force of of gravity allowed it to run down into that pan. This one was wet to begin with, so whatever hit that forced that water back out, so it got some additional. Then we've got our tillage pan. I always say this looks a little bit like yoo-hoo, if you know what yoo-hoo is. All runoff, all sediment. The scum that you see on the soil surface a lot of times is the biology that used to be in that soil that has come to rest on that upper level. There is absolutely no water that came through that pan into that down through that profile of that 2.5 inch pan. And then here's our pan with our same thing. We didn't get a lot in, but from a runoff standpoint, we got significantly less runoff. So what has happened is that cover that was placed on the soil surface, this mulch, has slowed down that raindrop impact and allowed that water to percolate a little bit further down in the pan. And if we were to take these pans, and I could take a knife and cut into them a little bit. Okay, so we're gonna look and see how deep this water went into this pan. Generally, when I do this in front of farmers, I end up flipping this pan over. That would be problematic, but we'll look and see how far we got moisture down into this pan. Since we had little to no runoff and we had little to no infiltration and we had all runoff. So you can see what's down here at about 1.5 inches to 2 inches is dry. That's why we didn't get the runoff. So when we take out this plug that's on the surface, this is how deep the moisture made it into this pan. It was about 1 inch, if that. And then we'll look at this one that had the protection. And right away, just sticking this spatula down into the pan, it's so much easier to get in because of the protection. And you can see it's pulling up. And from the standpoint of dryness, we have little to no dryness. So if we would have gotten a longer rainfall event there, over 1 inch of precip, it probably would have started infiltrating down into that pan. So there you can see it's completely moist all the way to the base, compared to we have a plug on this one and then dry soil underneath it. That's why it's so important to have this cover, whether it be living or dead, one or the other, needs to be there to keep this surface sealing from occurring, and then we get massive runoff. And then we have our cement pan. So like I said, the crack in the sidewalk in the front took in some water, not as much as we got from a runoff standpoint. So we got runoff. This is what we want our runoff to look like in an urban situation. Clean, clear. But does it look like that? Not always. Probably has a tendency to look a little bit like this. Has some stuff from our driveways and whatnot running down through that those storm drains and running off into our stream courses. So our goal is to try to keep this soil covered with living roots at all times if possible, whether it be in our native or cool season grass, or even our annuals in a construction situation. It's always good if we're building roads and having right-of-ways that we try to get some type of a living root out there as soon as possible. So a combination of mulch and living cover is always the best bet, because it takes a little bit for this to germinate, about a week, for these leaves to cover that soil surface. And in the interim, we've got that cover from that dead mulch till we get to this active blanket of really good cover here.